Now we're going to find some greatest common monomials when we have polynomials here. So if I look at our first term, we're going to have to factor the denominator. And I notice x goes into both of them, so I have x times x plus 1 over 3. And then here I have 9 over x plus 1. And over here, we still have 4 over x. So what is the greatest common monomial? That goes into all of them, greatest common denominator, rather. So, well, I have an x here and an x here, and then I have x plus 1 and x plus 1 here. So this is a factor of this, just we're missing the x. This is a factor of this as well, just we're missing the x plus 1. So if I was to turn this, each fraction into one that had the same denominator, I would have to do nothing with this because it already has both these factors. So we would still keep this 3 and x plus 1. For this one, we'd have to multiply the numerator and the denominator both by x because that's the factor that's missing. So we have 9x, so I have 9 times x is x, and then again x times x plus 1. For my last term, again, we're going to multiply everything by 1. Because x plus 1 divided by x plus 1 is 1. So I end up with 4x plus 4 over x times x plus 1. And so now I've converted all three of these fractions into a common denominator. Well, how does this apply with this question here? Well, we can do this a couple ways, and I'll talk about both ways. So this denominator, I can't do much. This denominator, I can't. I notice that y goes into both of them, right? So if I factor out the y, I'll be left with y minus 4 minus y over question mark, right? Is equal to 3 over 4 minus y. So the question is, what did I multiply this denominator by to get this denominator? Well, I multiplied by y. So therefore, what do I have to do to 3 to get the numerator? Y. So my numerator, or my question mark, is equal to 3y. The other way I could have taken a look at this is I could cross multiply, but that makes it difficult. So let's do this. For cross multiplication purposes, I'm going to call this x. I'm going to isolate the x. So multiply across, and I get 3 times 4y minus y squared is equal to x times 4 minus y. So then, multiply this out, right? Well, actually, I'm not going to multiply. What I'm going to do is I'm going to factor this, right? So I'm going to factor out a y, so I have 3y on the outside, and I get by 4 minus y on the inside is equal to x times 4 minus y. What's the opposite of multiplying x by 4 minus y? Dividing by 4 minus y. What I do to one side, I have to do the other. So I get x is equal to 3y. Either way works. Cross multiplication will become useful eventually, though. And then finally, our last, a little more complicated problem, we're trying to find the greatest common denominator for these. So, same idea. I'm going to break it into its factored pairs. So we have a. Now, what two numbers multiply together equals -10, but add together to get equal +3? Now, we did this in class today, right? So it's +5 minus 2. So over here, same idea. So we have a plus 5 and a plus 5. In this case, I do want to write it out. So what is the denominator that I'm missing? Well, my first one has an a plus 5, so it has this and it has this. Well, what piece is it missing? Well, it's missing one of these, right? So that means I'm going to have to multiply the numerator and the denominator by a plus 5. So then, I'll end up with 2 times a plus 5 over a plus 5. Now I'm going to put it squared because I have 2 of them. 1, 2. A minus 2. On this side, what am I missing? Well, I have this a plus 5, but I don't have this a minus 2. So we have a minus 2, so I'm going to multiply both the numerator and the denominators by a minus 2. So we get 4a times a minus 2 over a plus 5 squared times a minus 2. Gabe, are you done?
Yeah.
Okay, cool. And so I've done it. And that's it.
That for some official news, I suppose, on the first day of learning, right?